Very good, great. That is the case I started with. So if you see an integral that has that form, square root of a squared minus x squared, what should your substitution be? We just saw. A?
Yeah.
Just A? X is equal to A?
This is 14. A equals
A cosine theta. So, type 1. If you have an integral of the form or containing square root of a squared minus x squared, then substitution that you can use would be A cosine theta. But cosine is related to sine. Would it hurt if you used A sine theta? If you are a sinner, I love sin. So A sine theta will also work. Good. Remember when we did trigonometric integrals, I mentioned that you can either deal with the sine or you can deal with the cosine, and depending on your choice, the answer might look different, but you can go back and forth. With me? You see an integral like that, immediately your mind should go to a substitution of the form A cosine theta or A sine theta. Good? Okay. Type 2. Same would apply here also, right? A squared minus x squared, or with a root or any root. I can simply say a squared plus x squared. So it could be any expression containing a squared minus x squared, any expression containing a squared plus x squared. And if I asked you, based on everything I said, that x is related to cosine theta, y is related to sine theta, on a circle with some radius theta, what should you use as a substitution for x? Hint. It all started at number 1, moved on to number 2, then to number 3. And I said, I don't need number 2, number 3. All I need is that, right? To be content in life. So if you see something like that, what should your substitution be? Hint. I erased it. Go ahead.
never mind.
Substitution is never mind.
I'm trying to say it would be the same.
Will it be the same? It has to satisfy that identity, right? Think of number 2 and number 3. The ones I erased earlier, from earlier. Did we write number 2? What is number 2?
Secant square of theta equals 1 plus tan square of theta.
Okay, secant square theta is equal to 1 plus tangent square theta. if I multiplied both sides by a squared, I would end up having a squared secant squared theta equals a squared plus a squared tangent squared theta. They're all giving me a look, so I'll just write it. Multiply both sides by a squared, a squared, a squared, a squared. Agreed. What should x be?
Secant squared.
Secant squared. The form is a squared plus x squared. A squared plus tangent. So x would simply be a tangent theta. Good. Can I erase this one? One more time. Integral containing I did a squared minus x squared. I did a squared plus x squared. That leaves with one other option.
X squared plus a squared.
That's right here. So they're the same, right? So aside from what you just said, I have a squared minus x squared, a squared plus x squared plus a squared is the same as that. There's only one other option.
X squared minus a squared.
X squared minus a squared. Any form of x squared minus a squared. If you have x squared minus a squared, square root of x squared minus a squared, third root of x squared minus a squared, any of those, then I can use the substitution. What will I pick? The answer is right here. So, same expression from earlier right here. If you rewrote that, you would have a squared secant squared theta minus, move that a squared to the other side, a squared equals a squared tangent squared theta, right? Of the form x squared minus x squared. So if you see x squared minus a squared, square root of x squared minus a squared, third root, and so on, the substitution that you must see is a secant theta. But Caleb said, why not cosecant? Perfectly fine. You can use cosecant. Could you use cotangent? Perfectly fine. You could use cotangent. Why? There is that relationship between, cosecant, cotangent, secant, tangent. Good. What are the rules that apply with the secant tangent integral also apply for a cosecant and cotangent interval. Interval. So pretty much I took these cases that were in terms of a squared minus x squared, converted them to trigonometric integrals, and we know how to integrate them unless we encounter something, tricky.
My question is, why wouldn't the cotangent option be for number 2 here? That way they all have two different ones.
It could be. You can use a cotangent here, just like how I could use a cosine, a sine. I could use a tangent, a cotangent. I could use a secant, a cosecant.
But you also said cotangent for this one.
No,
Oh, okay.
a secant, a cosecant there, a tangent, a cotangent. I'm not saying a tangent, a times tangent, a times cotangent, a times secant, a times cosecant. I'm not getting into the cosecant cotangent part because we only discussed secant tangent integrals, and I simply mentioned or made a remark that if it works with secant and tangent, it is going to work with cosecant cotangent. Right? Are we clear? Do we understand the three types? Okay.